Hi, in this video, we will be focusing on finding or determining the direction of the magnetic force acting on a wire carrying a current within a magnetic field. Okay, still we're going to use the right-hand rules, where the thumb in this scenario will be going with the direction of the current. My four fingers will be presenting the direction of the magnetic field, and the hand palm will be presenting the direction of the magnetic force acting on that current or that wire. Okay, so in this example here, a straight long wire carries an electric current to the right. That's the direction of the current. The current is placed in a uniform magnetic field directed into the page. What is the direction of the magnetic force on that current, or technically on the wire? So what we're gonna do, here we go, that's my thumb going with the direction of the current through the wire. My magnetic field will be going into the page, into the away from me, and my hand palm will be presenting the direction of the force, which is upward or north. One more time, quick. Thumb with the current, fingers with the magnetic field into the page. The hand palm will be presenting the force direction, which is upward or to the north. So that will be the direction of the magnetic force acting on this wire. Okay, let's try another example, maybe a little bit different scenario. I have here again a straight long wire carries an electric current to the top of the page, or it's going to the north. The current is placed in a uniform magnetic field directed out the page. What is the direction of the magnetic force on the wire or on this current? So once again, what I'll do, that's my thumb going with the direction of the current, my magnetic field, the fingers pointing away from the page, out of the page, or toward me, and the hand palm is pointing to the right or to east. So this one will be the direction of my magnetic force acting on this wire. Let's try another scenario. Here we have, let's get closer so you can read it. Right. Now I have a wire carrying a current going to the north. The wire carrying a current going to the east or to the right, where the magnetic field is going to the north. We've been asked to determine the direction of the magnetic force on this wire. Now, once again, my thumb showing it's going to the east, the same direction of the current. My four fingers pointing north, and that will be leaving us the face or the direction of my hand palm going out of the page toward me. So it's coming out. That will be the direction of the force, of the magnetic force. So I can make a dot, circle, and that will be the direction of the magnetic force acting on this wire. Another example. It says determine the direction of the magnetic force acting on the current. Okay, now the magnetic field is going into the page, okay, and my wire is directed in an angle where it is northeast. So we're still going to apply the right hand rules, nothing changing. So what I'll do, my thumb will be doing an angle the same direction of the current, going that way, it's northeast. My four fingers pointing into the page. So as you can see, my hand palm pointing this way, which is the northwest. One more time. Current northeast. Fingers with the magnetic field going into the page. My hand palm pointing northwest. That will be the direction of the magnetic force acting on this wire. Okay, one more scenario. Let's bring it closer. I have a straight long wire carries an electric current out of the page. The direction of the current is out of the page, coming toward me. The current is placed in a uniform magnetic field directed into the page. What is the direction of the magnetic force on the electron? Well, as we discussed that in the positive charge within a magnetic field video, we can see that the angle between the wire and magnetic field, we can say it is equal 180 degrees, which means the force, it will be ILB sine theta, it will be 0. There will be no force acting on this wire as long as it's making that 180 degrees, the angle between the wire the current direction and the magnetic field direction. Okay, one last example. This one is a bit interesting one, where you have a combination of a wire carrying a current and a negative charge around that wire moving to the right. Let's see. A negative charge moves away from a current carrying wire. What is the direction of the magnetic force on the charge? So let's focus here. He's talking about the magnetic force acting on that negative charge. Okay, so which means if there is a magnetic force acting on this charge, there must be a magnetic field surrounding that negative charge. So to find where is that magnetic field or the direction of that magnetic field, we have to focus on this wire, which is carrying a current. Based on the right-hand rules, the first right-hand rules, I can see that I have a wire carrying a current going to the north. And if I apply the first right-hand rules where I can turn my right hand around the wire, I can see that in this region here, the right side of the wire, my fingers is going into the page. That's the direction of the current. That's my fingers, like my nails going into the page. So in this region, the magnetic field is going into the page. That's the magnetic field direction. I'm not going to worry about the other side, even we can tell where is it, it's out of the page, but we will focus on the right side where the negative charge is located. Now I have a negative charge moving with or entering a uniform magnetic field with a certain velocity toward the right or toward the east. This negative charge will be facing some magnetic force acting on it. Let's determine the direction. Now we're going to use the second right-hand rules, where I have my thumb is going with the same direction of the charge or the velocity going to the east. My magnetic field going into the page, But for the force, as we mentioned in our previous video, for the negative charges within a magnetic field, we use the back of my hand, and that will be representing the direction of the magnetic force acting on this negative charge. So the force will be going this way. Okay, so for such an example, we have to figure out where is the direction of the magnetic field in the region where is that negative charge is, by using the wire carrying current, because we know that if there is a current in a wire, there is a magnetic field around that wire. So we managed to identify the direction of the magnetic field. Then we use the second right-hand rules to identify or determine the direction of the magnetic force acting on this negative charge. That's it for this video. I hope you enjoy it, and we'll see you again with another one. Thank you.